a member, okay, ma, A, B, C, D is subjected to an subjected to sorry not an point loads P1 E1 comma P2 comma P3 and 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 P4 P4 as shown in figure figure calculate the force P3 necessary for equilibrium if P1 equal to 120 kilonewton, P2 equal to 220 kilonewton and P4 equal to 160 kilonewton. Okay, determine also the net change in length of the member take capital letter E equal to 2 into 10 to the power 5 Newton per mm square. As usual, we have different length, different diameter component is there. Okay. Then, as usual, we have the different length. Point 0.75 meter, 1 meter, 1.2 meter, and then here 40 by 40 by 40 mm, 25 by 25 mm, 30 by 30 mm, and then here we are applying the load P4, this one is P3, P2, this one is P1. Okay, and then here we have right ABC corner of that object. So we can write as usual the given data in the diagram itself. I don't waste the time. So I can write L1. So better to convert into meter to mm. How much mm? 0.75
into 10 power 3, sir.
10 to the power, because 1000 mm equal to 1 meter. So 10 to the power 3 mm. We can convert in the diagram itself. L to 1 meter. So 1 meter is nothing but 1 into 10 to the power 3 mm. We can save some time. L3 1.2 into 10 to the power 3 mm. And then P4, how much, ma? 160
160
kilonewton.
kilonewton.
1 kilonewton. I won't convert into Newton. Later I will convert because I want to tell you something. Because we want to calculate P3. That time some little bit confusion is there. So to avoid that one, I can keep as it is. Then we can substitute that kilonewton to Newton. P2 how much? 220. Okay. P3 we don't know that one. Leave it as it is. P3 I can put question mark. Okay. This is A1. A1, A2. What is the area formula, ma? Particular for this component.
B into D, sir.
1600, 40 by 40. That's all. Need not to use B into D or anything. Because they are clearly they given the, it's a square body, 40 by 40. Are you understand the logic, ma?
Yes, sir.
Okay, fine. Now, in given data, what we have to write normally? In the given time, only Young's modulus, no? Because other things we written nicely there in the diagram itself. So, E equal to 2 into equal to 2 into 10 to the power 5 Newton per mm square. Clear? So what is the requirement, ma? What we have to find? Just read the problem and
P,
say
P3.
P3. P3 necessary for equilibrium. So we want to find P3. Next one, ma. What is net change in length? I underline the problem side. Check it that one. What is the net change in length?
DL. DL.
DL. That's all. Change in length is nothing but DL. Net mean total. Total change in length. For the three component we have to find. That's all, ma. So solutions. How do you find that P3? Okay, leave it. What is meant by equilibrium, ma? Suppose the body maintains the same position, that's called equilibrium. No, am I correct? Suppose there is no balance, unbalanced force. Okay, so now check it here. Here we have body. When the body becomes same positions, we are pulling right hand side, left hand side, something like that. So when the body become equilibrium, same positions, tell that one. Suppose left hand side force equal to right hand side force. Am I correct? Then the body becomes same position. Now you are pulling one side, your friend pulling on the opposite side. Suppose both the force are same. The middle person may be sitting in the same position. Am I correct?
Yes, sir.
So left hand side force equal to right hand side force.
Right hand side.
Upward force equal to
Downward force.
downward. That's all. So here we would like to use a equilibrium concept. Okay, resolving force is nothing but suppose you are solving all the forces, that's called resolving forces. Okay, here we are, want to solve the forces. What we have to solve? Left equal to right, because we don't have the up and downwards. Only thing is we have left and right. So I can write left and right. So check the diagram and tell how many forces acting. What are the forces acting in the left hand side? P1, P2, P3, P4. Four forces there. So among the four forces, what are the forces acting in the left hand side, ma?
P1, P3, sir.
P
1, P3.
P1 as well as P3, correct only. P1 and P3, check the diagram. Both are acting in the upward left hand side directions. So P1, okay, fine. Right hand side, ma.
P2, P4.
P2, P4, that's that concept only we have to use in the resolving time also, engineering mechanics time also. P1 how much, ma? Quickly tell.
120 kilonewton.
120, okay. P3, we don't know that one, we can keep as it is because we want to find P3 only. P2, ma.
220.
P4.
160.
160. Now tell what is a P3, ma? 220 plus 160 minus 120.
260.
260 kilonewton. So what is the P3 ma? 260. So any difficulty to find that value of P3?
No, sir.
No, easily we found that one. Now we want to find the DL. So quickly tell what is the DL formula ma? As usual, E equal to DL by L, DL equal to E
E
into
into
L.
L.
So okay, what is E? Here we don't know the E. Anywhere E is there? No. What is E ma? Young's modulus equal to
Doing.
stress
Stress by
divided by
strain.
strain. So strain equal to stress divided by Young's modulus. Am I correct? So shall I substitute there? DL equal to sigma divided by E into L. So do you know the stress ma here? Anywhere stress is there?
No, sir.
No. What is stress formula ma?
Load by area.
Load by area. So shall I write that value also here? So what is DL? Load by area and then L by E. Am I correct? PL divided by AE. Correct only no?
Yes, sir.
So DL equal to DL1 plus DL2 plus DL3. So what is DL1? P1 divided by A1 into L by L1 divided by E. Am I correct ma? Plus DL2, that is P2 L2 divided by A2 E. Correct only, no? Similarly, P3, yeah, DL3, P3 L3 divided by A3 into E. Is it okay, ma'am? So, shall we take Young's modulus outside? We can take outside. Other things I think we cannot able to take. So, P1 L1 divided by A1. Always simplify the equations, ma. Okay. Exam time better to simplify the equations. L2 divided by A2. Within 1 minute we can simplify. P3 L3 divided by A3. The formula okay, ma?
Yes, sir.
Okay, ma. Now I can substitute the value. 1 divided by E. E value 2 into 10 to the power 5, no? Okay. What is P1 value, ma?
120 kilometer.
120, but I have doubt. What I have
Kilonewton.
Into
doubt, no. Wait, I'll tell you what doubt I have that one. This is the first part. Okay? We have the first part like this. Okay. So understand the concept properly, ma. Listen properly. I am pulling the component 120 here. 120 kilonewton. Understand the logic properly. 120 here. At the same time, here in the original diagram, first diagram, P2 also there, no? What is the P2 value, ma?
220.
So whether we want to use 120 or 220 in the formula. Now we have doubt, no? This is the first part. The first part, we have two forces acting. Am I correct? The second one. P1 and P2. Which P we have to take? P1 எடுக்கணுமா P2 எடுக்கணுமா? Which force we have to take? We have confusions. Am I correct? Yes or
yes,
no?
sir.
Yes, sir.
Yes. So now we have to use one concept, ma. The thermodynamics as well as strength of material, we are using very, very important term that is called equilibrium. Equilibrium you should not forget. How you are sitting in the your chair, how you are lying on the bed, the equilibrium only. How much load acting downwards, same load acting in the upwards. Am I correct? Your weight acting downwards, same load acting in the upwards, no? Then only you are sitting nicely in your chair. Am I correct?
Yes, sir.
So equilibrium word is very important. Now tell when the first body become equilibrium, same positions. When? Suppose left hand side 120 now. What about right hand side ma?
120, sir.
120. Okay, then only the body maintain equilibrium. So now tell what is P1 ma? This is P1. You understand this one? New P1. Just forget the old one. This is P1. Do you have any doubt with the P1?
No, sir.
Okay. Next one, I'll take the last component. This is a third component. Ma. Okay. I'll write the third one. Okay. Third one, right hand side, how much, ma?
160, sir.
160. Okay, ma. 160 kilonewton. Okay, fine. So when the body become equilibrium?
Left hand side also 160.
160. So what is the name of the force? P3. Am I correct? Third component. Now shall I call the P3?
Oh, yes, sir.
So P3 also we know that one. Now we have only one problem at the time of second component. Okay. Second component I can draw. Okay, fine. So here understand the logic properly now. Carefully we have to solve. Listen properly. Now the first talk about that, listen properly ma. I am talking about only second component. I am talking only about second component. In the second component, two forces acting in this area. Am I correct? I can put red color. No, just observe that one circle. I put it that one in the diagram. P1 and P2 acting there. Am I correct?
Yes, sir.
At point B, two forces acting P1 and P2. So listen properly, ma. Tensile forces always positive, compressive negative. Now tell 120 is there, no? That is tensile force, no? Am I correct?
Yes, sir.
So positive or negative?
Positive, sir.
Positive. So 120 plus 120 kilonewton. Okay, fine. Check the second component. I'll come to the original first part. P2 is a compressive or not, according to the diagram. According to the diagram. According to the
Compressive.
second part, compressive or tensile?
Compressive, sir.
Compressive, positive or negative?
Negative.
How much that one? P2?
220, sir.
220. What is the difference, ma?
Minus 100, sir.
Minus 100 kilonewton. Okay. Minus means compressive or tensile.
Compressive, sir.
Compressive.
So check the arrow, ma. How I am written that arrow. This is P2. P2 is 100. Are you understand the concept, ma? So what about the right hand side, ma? What is the value?
100 kilonewton.
100 kilonewton compressive. But we have doubts, sir. How can I believe, sir, whether it's 100 or not? I can prove that one. Now, ma, just concentrate only this circle, ma. Just concentrate this side. How many forces acting that circle? What are the forces acting there?
P3.
P3 and
P4.
P4. Correct only, no? P3 and P4. P4 is tensile or compressive according to this diagram.
Tensile, sir.
Tensile, we are pulling, no? Check the third component. We are pulling. So tensile. So 160 kilonewton. But P3, ma, compressive or this one, tensile, according to the second component.
Compressive.
Positive or negative?
Negative.
How much?
260.
So what is the difference?
Say minus 100, sir.
So it's proved, no? Already we written 100 only, no? Minus 100. Minus means nothing but compressive. Is it correct?
Yes, sir.
So do you know how do you calculate the forces, ma? P1, P2, P3.
Yes, sir.
Okay, ma? Now that value only we have to write here. What is P1 value? 120. 120 kilonewton, better to convert into Newton, ma. 10 to the power 3. What is L1, ma? 0.75 meters. So 0.75 into 10 to the power 3, no?
3. Yes.
Area, ma?
1600.
Yeah, 40 by 40. I can write like this. 40 by 40. P2, ma?
Minus 100, sir.
Good. That's all when you understand the subject. Minus 100. Compressive. So put minus. Okay. 100 into L2, ma? 1 into 10 to the power 3, no? A2, I think 25 by 25. Am I correct?
Sir, P2 வந்து 100 into 10 power 3, sir. Minus 100 into 10
Sorry,
power 3.
10 to the power 3. I forgot to write the 10 to the power 3, no? Good. So better write 10 to the power 3. Suppose I am doing mistake, now just tell quickly. 10 to the power 3. 100 into 10 to the power 3 multiply 1 into 10 to the power 3. Am I correct?
Yes, sir.
Okay, P3 is a tensile. How much we found?
160.
160 into 10 to the power 3 multiply. What is the length, ma?
Point.
1.2 into 10 power 3.
1.2, no? Yeah. Because I am not checking my class notes. I am concentrate only screen. What is the area, ma?
30 into 30.
30 into 30. Okay. So can you able to solve this step, ma?